Okay, so second year of Technographics. Up until this point, we've been doing transformation geometry. This here now is the next stage in your transformation geometry question. This is very similar to what you'll be getting in your higher level paper next year, and this is the way the question is set up. So we've got the figure here, alright, so it's 50 millimeter square sitting at an angle of 45 degrees. Okay, so t square and z square, and it's 50 millimeters long. It's got this arc on it here. That's pretty straightforward to draw. We just measure it here and slide the arc down, and this is a diagonal here going across. So that's the figure, and it's going to be subject to transformations from A to A1, A1 to A2, A2 to A3, A3 to A4. We've got this set up on our standard A3 sheet. Okay, so this is the approach I want you to use for this question. So I've got the start point here, down 75 in 80. So measure down 75, draw a horizontal construction line, measure in 80, draw a vertical construction line. That's going to give us this point A here. Using our 45 degree set square, we're going to draw the figure. We're then going to set out point A1, A2, A3 and A4. Notice the way all my lines are construction lines, and I've marked in A, A1, A2, A3, A4. Okay, now first things first, I'm going to mark the points. So I'm going to mark this as 1, this is A, this is 2, this is 3, and this is 4. Okay, so I'm going to number the points. Right, now the next thing I'm going to do is I'm going to draw a line from A to A1, A1 to A2, 2 to A3, A3 to A4. Now, okay, now I've drawn this line in red to highlight it to you at home. You can draw that in with a light construction line, or you can do it in a red pen. That's okay too. Leaves it clear for yourselves. Right, again, this is a different approach to what we've been doing so far, and that's why I'm showing you like this. Okay, so if we refer to the question, okay, so in the question they say A to A1 by central symmetry, A1 to A2 by axial, A2 to A3 by rotation, A3 to A4 by translation. Now, the first thing I'm going to do is I'm going to bisect this line from A to A1. So to bisect the line, set the compass at one end, make sure it's over halfway, draw an arc above and below. Okay, now I put my point at the other end, arc the other way. Where those arcs cross, I'm going to draw in my bisector. And again, that's light construction, that work. Okay, barely visible there, but I put in okay, I'm going to go on to A1 to A2, make sure it's over, the compass is over halfway the distance of the line, arc above and below, point here, arc above and below. Okay, do the same here, compass at one end, make sure it's over halfway the distance of the line, arc, don't change the setting on the compass, point the other side, arc, point here, okay, bisector. Now This last point, A3 to A4, is translation. I don't need to bisect this one. Okay? So for translation, I don't need to bisect the two lines joining A3 to A4. So I'm just going to leave that. So I bisected this line, and this line. Okay? Now, the first one we have to do is, referring to the question, is A to A1 by central symmetry. The central symmetry we are dealing with here is this point here, where the bisector hits this red line. We'll call that S. Okay? So all points go through S and they go equal distance, right? So if I come down, now, the first point is done for you, right? Because I know if I come to here, I compass on the point and measure to A and flip it around, then the new point for A is A1 there. So that's already done for you, right? So I'm going to take point 4. I'm going to draw a line from 4 through S. Okay? I'm going to measure with my compass to 4, and I'm going to swing it round, and there is my new position for 4. Okay? Notice the way I'm doing one point at a time as well. So line up to 2, draw a line from 2, point on S, measure to 2, new position for 2, dot 2. I'm going to go to 3 next, point to 3. So what has changed now is you're not given the central point or you're not given the axis, you have to draw those in yourselves. So that's the only change from the previous questions we were doing. Okay, and the last point here is point 1. So this is central symmetry all through the point S, which we have gotten by bisecting the line between A and A1. There's 1, new position for 1, mark it in. So if I go back to my figure, 1 joins to A to 2. So 1 joins to A joins to 2, okay, 2 joins to 3, 2 joins to 3. Now from 3 to 4 there's an arc, okay, so if I go here, okay, I join 1, 4, there we go. So that's central symmetry in the point S. Okay, so that's our first one done. Okay, so that's our central symmetry. Alright, so I'm going to come along here and I'm going to write in central symmetry. Central symmetry. Okay. Now, the next one from A1 to A2, if I refer to the question, is axial symmetry. And axial symmetry is on an axis. So we've joined the line between A1 and A2. We've bisected that line. So we've produced the axis. I'm going to put in that axis in green to highlight it for you at home. Okay. Now remember what we said about axial symmetry. All points go through the axis at right angles. Right? So that line from A1 to A2 is at right angles to the green line. Okay, and they go equal distance either side of the axis. So if I get my compass, measure, okay, so that point A1 to A2, look, measure, flip it, that's equal distance, and I can see that it's at right angles. Okay, so all my points are going to go through at that angle there. Right? So again, we use the same approach. Take one point at a time and note it. Okay? So I'm going to move my T-square. So I'm going to make sure my big set square, my 60/30, is parallel with that line. I'm going to hold my T-square and slide back the set square. Now I'm going to take point 1. So now point 1 and this line are parallel. Okay? And then I'm going to get my compass. I'm going to make sure you can see it. I'm going to measure to 1. I'm going to flip 1. There's my new position for 1. Mark it in. Okay? Again, line up, parallel, slide back. We'll take 4 this time. I know it's at right angles to the axis. Measure to 4. Flip. There's a new position for 4. Okay, next point. Line up. Make sure I'm parallel. Slide back. Measure to 2. Flip it. New position for 2. Extend this line slightly. There we go. There's 2. And the last one now is 3, so line up parallel. Slide back. So you can see all these lines are parallel and they're all at right angles to the axis. Point on the axis, measure to 3, flip 3, new position 3. Now, the figure or the image joins up in the same way. So A to 1, A to 1, A to 2. So let's do that. A to 1, A to 2. Alright. Now 1 joins to 4, 1 joins to 4. Okay. 2 to 3. 2 to 3. 2 to 3. Now lastly, my arc, so I can check my arc here. 1 to 4, 1 to 4, slides back, and as you can see, because it's axial symmetry, the image flips. So the image flips, it's a mirror image. Okay, so let's put that in. Right in X, I, L, S, Y, M, M, E, T, R, Y. Axial symmetry. Okay, so axial symmetry. Okay, so what's happening next from A2 to A3 is they say that it's a rotation clockwise through 120 degrees. Okay, to be honest, this is the trickiest one of the transformation geometry questions you'll meet. This is what will come up at higher level in your junior certificate next year, and if you can manage this, you'll manage this question no problem, and you get full marks. Okay, so I've joined A2 to A3, and I've bisected that line. That's going to come in very useful for what we have to do next. I've got a piece of tracing paper here. Okay, and I've gone over the tracing paper and I've gone over the figure. Now what's happening here is this figure is rotating round, right round, and A is going to end up down here and the other points are going to end up like this. So if you like, it's rotating clockwise, this is clockwise, 120 degrees. And the bisector here is going to come in useful for what we have to do. Okay, so what we're going to need, because we're dealing with degrees and rotation, is we're going to need our protractor here for this question. Now, I joined A2 to A3 and I've got a center line here. So we've got to set up this rotation in here, and it needs to be at 120 degrees, right? So if we think about this, down here, what I have is I've got a triangle here, right, and in here it needs to be an angle of 120 degrees. So if it's 120 here, what does it need to be in here? Well, it needs to be 30 and 30. Okay, so this angle and this angle are equal. They're at 30 degrees because the overall needs to be 180 degrees. Is that fair enough? So if this is point A3 and this is A2, this is our base of our triangle here, and this angle in here needs to be 30 and this angle here needs to be 30. Right? So if I get my protractor, I line it up here with the line and I set off 30 degrees. I join from there through. Okay, now I don't have to set it up here because I know if I join from here to here. Okay, now if I want to go in and check that, put my protractor down, measure round, and I'm at 120 degrees. So from here right round, that's a 120 degree rotation. So the point A1 is done for us. This point in here, we call it R, the rotation point. All points are going to rotate around this point R. Okay, so the first point A is done for you. Now, let's do one other point. So I'll keep my protractor up here. I'll do point 2. So I'm going to join a line from 2, right? Then I'm going to get my protractor. I'm going to line that up, right? So the center point R to the point 2, to that line, I'm going to come around 120 degrees. So I know somewhere along this line, because I know that rotation from there to there is 120 degrees. Somewhere along this line, that point 2 exists. Now, I'm going to go back to my compass. Right. I'm going to measure to the point 2. I'm going to rotate round. And there is the new position for 2. Okay. Let's try another point. Let's try this point 1. It's really flat here. Point 1. Get my protractor. Line up with 1. Come around to 120 degrees. There we go. There's the point. Measure out. Okay, I know somewhere along that line that's 120 degrees. Now get my compass, point here, measure to 1. See that there? Measure to 1 accurately. Rotate round. There's the new position for 1. So I've got 1, 2. A is done. Let's do 3. 3 is close to 1. A bit out. There you go. I'm going to extend that line just for ease of work. Now 3 is out here. Measure to 120 degrees. Measure it out. Point to my compass. Measure to 3. Rotate around. There is 3. I've only got 4 left to do now. It's 4 to the rotation point. Extend that line out. Protractor down. 120 degrees. It's there. Back to the rotation point. There's 4. Measure with my compass. Up to 4. Point here. Measure out. 4 and 2 are very much on the same line. There's 4. It's a bit tricky for that point 4. Be careful of it. 4. Now, I've got all the points. I need to join them in the same way. So A joins to 1. A joins to 2. So A joins to 1. A joins to 2. Two joins to 3. 1 joins to 4. 2 to 3. 2 to 3. 1 to 4. Okay. Measure 1 to 4. Join the arc. 3. Okay, so I've made a mistake here in joining 1 to 3, so I've rubbed that out and I've joined my image in. So that's the rotation. We've taken our piece, we've rotated it right round into its new position. So it's a 120 degree rotation clockwise. Okay, so I'll take away my tracing paper. I'm going to write in. So rotation 120 degrees clockwise. Okay. Now, all done. I'll move this away. Take it out a bit. So we've done our central symmetry, our axial symmetry, and our rotation. The last one from A2 to A3, that's translation. So all points are going to move at this angle by this distance. So again, what I'm going to do here is I'm going to take my 2 set squares, I'm going to line up that line, I'm going to hold the bottom set square, and I'm going to move point 2. So now that line and that line are parallel. Now the distance is too great for my compass, right? I can't stretch my compass to that distance. So what I'm going to do is with my large 60-30 set square, I'm going to measure it. I can see the distance there is 2 to 4 millimeters. So I'm going to go to here. That's my new position for 2. Okay, and I'm going to do the same with the other points. So again, my two set squares line up parallel, hold the bottom set square, slide, and this is 3. Okay, that's point 3. Check that this is again 224 millimeters. Okay, 24 millimeters. Okay, here's the new position for 3. Okay, and do the same for 4 and 1. I'm going to let you all finish that off. Take your time with it, go through the video, stop it at the points, and if I haven't explained anything, come back to me on the classroom, ask me a question by all means. Again, this is higher level standard. This is the most difficult this question is going to get. It's definitely going to come up in your junior cert next year. I can guarantee you transformation geometry will come up. That's why I'm spending the time on it now. Alright, well done everyone.